Right. The reason why we choose BGP as a routing protocol is for the attribute. So, these attributes allow us to select a path as per our policy, not as per the bandwidth availability or number of hops or a delay, but as per our policy that you are expecting a packet to travel to reach a destination. So, knowing attribute is more important. We know how to configure BGP, enable BGP, advertise a network in BGP. We learned about next hop self, update source, eBGP multi-hop, TTL security, and all of the fundamentals about BGP. Now this portion that we are going to see is what we consider as an advanced portion in BGP. So far we have not seen advanced. All that necessary thing to make BGP work is covered. But the advanced thing, policy-based path selection, tuning BGP's attribute is very important. See, if we don't have these attributes, then there is no use of BGP. Attributes makes this protocol very special. So selecting a BGP path is using the attributes. We don't have BGP focusing on better bandwidth or reliability or MTU or delay. We got BGP metric, which focuses on the other various things which will be easy for the policy in path selection to be applied. So we don't call metric, we call it as attribute. BGP metrics are called as path attributes. Path attributes. Now these attributes, depending on the characteristics, they are classified as below: well-known, mandatory, transitive, partial, optional, discretionary, non-transitive. Well-known versus optional, mandatory versus discretionary, transitive versus non-transitive. We'll see what these are. But few things you already understood here. Well-known means what? Those attributes that are well known to every vendor, not only Cisco, not only to so-called Juniper and Huawei, even for every BGP appliance that runs, the appliance that runs BGP definitely will have the attribute which we call well-known attribute. Well-known. Well-known. Whether it is small or big, every organism breathes. Without breathing, no living organism. It's well-known story. Well-known. Likewise, every BGP appliance will have few attributes for sure. They're called as well-known attributes. In that, few are mandatory. If not present, it's not considered as a BGP update. So if when I receive an update, those mandatory attributes which are meant as mandatory should be there. Otherwise that update is null and void. That's mandatory. Definitely it should be there. All all mandatory attributes are definitely well known also, because it is mandatory. Everyone should have. See, all mandatory will be a well known one, but not all well known can be a mandatory. Transitive, if it is present, updates are going to be considered as valid. If it is not valid. We'll talk about this in detail much more when we go inside. So, to an extent, I have given you an idea of what is well known and mandatory. Is mandatory and well known same? No. Well known, known to every BGP vendor, runs on every BGP router, every BGP appliance. In that well known, some are mandatory. It should be there. If that attribute is not there, that update is not valid. All mandatories are well known. Some discretionary is also well known. What is discretionary? May be present, may not be present, but they are well known. Now let's see. What is well known attribute? A well known attribute, or the attributes that must be recognized by all the compliant BGP implementation. Means it should be seen. And they are propagated to other neighbors. So well-known attributes, or the attributes that must be seen on every BGP implementation. And these attributes are always propagated to other neighbor. But in this there are two sub-classifications: well-known mandatory attribute, well-known discretionary attribute. When we say mandatory attribute, must be present in every BGP update. When a router sends an update about some destination network, along with the destination network information, this attribute is sent. Always sent. Because it must be present on every BGP update. It's well known and always present. Well-known discretionary attribute may be present. Though it is well known, may be present. If sender didn't send, then can't be seen, no? So, though it is popular, there is an option to send or not to send. Those attributes are called as well-known discretionary attributes. It is well known, but the sender is not willing to send. So when I receive the packet, it is still valid because it is not a mandatory to be seen. Though I don't see the attribute, I still agree, accept it because it is not a mandatory well-known. It's a discretionary well-known. Discretionary well-known. So the attributes that may be present in the update message maybe is a well-known discretionary attribute. The attribute that must be present in the updates, they are mandatory well-known. You see, we have covered this. We know what is well-known. Must be seen on every BGP implemented devices. They are propagated to neighbors. And if it is mandatory to be seen on every update, those well-known attributes are called as well-known mandatory. Means must be present. If you have a well-known attribute which may be present, may not be, then they are discretionary. Next, optional attributes. They are recognized by some implementation, could be private. It's not an attribute. It is not an attribute that every vendor knows. So it's opposite of well-known. It is not an attribute that are popular. It could be private because they are not recognized by every, only some, but expected not to be recognized by all BGP routers. So those attributes that are not really expected by every BGP routers, maybe there may be some attributes which are only on Cisco devices. Some attributes are only on Juniper devices. If you have something like that, then they are optional attribute. Recognized optional attributes are propagated to other neighbors based on their meaning. It's optional and they are also propagated. Now, we understood the meaning of what is optional attribute. What is the meaning? They are not expected to be recognized on all BGP appliances because they are local, they are private to some vendor. But depending on the meaning, the attribute, they are propagated and used by the receiver. Now in that optional attribute, there are two subcategories depending on the receiver. If a receiver says, though it is an optional one, here let's say this point, though it is an optional one, I must see that. If I don't see that, I will discard the update. Though it is an optional one, for me I want. If I don't see that, I'll simply discard the update. I will not accept that update as a valid one. I will not accept it as valid one. So those attributes are called as optional non-transitive attributes. We saw optional means not everyone will be having that attribute while they send. But for the receiver, if it is mandatory to be seen, if not seen he will discard, then it is called as optional non-transitive. If not recognized, see, there may be some routers, they expect that optional attribute, but if it is not recognized, if it is not seen, they're not going to discard it. They are going to propagate it to other neighbor, marking it as partial. Such attributes are called as optional transitive. Optional means not well known, not everyone knows it. If it is seen, a meaning is given. If it is not seen, then they are considered as partial, and the update is still used, propagated to other neighbor. That is optional transitive. Optional non-transitive is if it is not recognized, it is discarded, not going to be utilized. So we have learned the meaning of optional, transitive, non-transitive, marked as partial. Optional, the receiver marks it as partial and propagates it. That is what transitive optional. Optional, the receiver wants to see it. If it is not seen, he will discard it. Then it is non-transitive, optional non-transitive. Please ask me any questions if you have. Sam,
understood but not clear. Once we get the example actual in there, then we'll be more.
Okay, the definitions are well understood. That's what you are saying.
Yes.
Okay. Sam, do you have any question?
No, sir, but would like to see more about it.
Now, we're going to see more about it. BGP attributes, we'll see with some example. For example, AS path is one of the attribute. Autonomous system path. We learned BGP is a path vector protocol when it advertises some network. Not just the network is advertised, attributes are advertised. One of the attributes that we used to see is the AS number via which the updates reaches. The AS path, the autonomous system through which the attribute reaches us. So, AS path is one of the attribute. BGP's attribute, AS path. It is a well-known, mandatory. You see, everything that has got star or well-known means every BGP vendor, means every vendor who runs BGP will have this. And it is mandatory also. If it is not seen in any one update, that update will not be processed. It won't be a valid update. That's why it is mandatory. It's not discretionary. What is discretionary? It may be present. But what we are learning about AS path. AS path is well known, mandatory, must be present in every BGP update. Yeah. So AS path is an attribute that must be, and everyone knows about it because it's important. Because it's a path vector protocol. You should see the AS, autonomous system. So it is definitely a well known because every BGP will be having it, whether it is run on a Cisco device by Cisco or Juniper device by Juniper or Huawei by. Everyone will have this, well known. And if it is not seen, it is invalid update. Then it is called as mandatory. If it is not seen, it is invalid, meaning it must be seen. Likewise, the next hop is also well known and mandatory. Next hop means which IP address is the next hop to reach the destination. This is your autonomous system, this is another autonomous system, this is another autonomous system. So from here, should I go here to this gateway or to this gateway? Which gateway? Should I go to A or B? That is what next hop. That is also important. So when the network is advertised, A puts its own address and sends. That address is what we call it as next hop address. For router alpha, A is the next hop. When some other network comes via B, B puts its own address. For some other networks, for alpha, B is the next hop. Let's say 1.1.1.1 is coming this way, 2.2.2.2 is coming this way. For alpha router, the AS path to reach 1.1.1.1 is autonomous system 10. The AS path to reach 2.2.2.2 is autonomous system 11. And the next stop to reach 1.1.1.1 is A. Next stop to reach 2.2.2.2 is B. That is about the next hop. Next, the origin. From where it is advertised. Is this network that I am receiving advertised locally on this router or given by the next neighbor? How I am learning this? Is it because of my own advertising it or learning from different neighbor? Where it originated? Sam, did you ask me anything?
Well, I thought you were asking a question. I just said, yeah, learning from the neighbor.
Yeah.
Origin.
So that origin, it shows from where, local or from remote. It's well known and mandatory. Let me take you to an example for origin here. I don't have a picture, but this is what explains the I is the origin code. If I have a question mark, instead of I, that means different thing. Now what is I and what is question mark? We will discuss in detail as we come here, when we come here. So now there is origin, which I explained. There is also origin code. In the attribute list, if you see, you will see two type of origin. Origin, whether it is local on this router or learned from another router, is one type of origin. Another one is the way it is injected. See, if you are learning a network in this routing table by BGP, there are two ways in which you might have learned this. One, somewhere someone advertised it, so you are learning it. Someone somewhere in BGP, they advertised it, so you are learning in this router. All are BGP routers. So through BGP you are learning it, because somewhere in the remote router, someone advertised this network inside BGP. Next, the other chances are somewhere someone redistributed it. See, that is also possible, no? If you are learning a network here, maybe someone somewhere took a static route and redistributed into BGP, or took a OSPF route and redistributed into BGP. So when you learn a route, it may be because of advertisement using network command. It may be because of redistribution. That is also explaining how it is originated. How that network introduced into BGP. How it is introduced into BGP. Whether it is through advertisement using network command or through redistribution. So this origin, next hop attribute, AS path attribute, all these attributes are well known and mandatory. There may be some well known, but may not be mandatory. For example, you see, well known but discretionary. Which one? Local preference. So this is well known but discretionary. Though MED is well known, so it is listed under well known, but we don't call it as well known. MED is known to everyone actually, but we don't call it as an well known. It's an optional one, optional transitive one.
So what does the MED stand for?
Multi-exit discriminator. Optional and non-transitive. I'll come and explain you when we go here. It's called multi-exit discriminator, MED. Okay, so this is not the only attributes we have. We have many. These are not the only attributes. There are many more. Here, only those attributes that are configurable, that can be manipulated by us, is shown here. But we are going to see more attributes, but mostly they are all utilized dynamically. Not you cannot configure them. You will be able to change the next hop, origin code, local preference, MED. You can also even change the AS path by writing some route maps. You can use these things to manipulate the path selection. But the other attributes are utilized, that's all. You can...
So wait also.
Come again?
Wait. Wait attributes also, it can be configurable, sir.
Yeah, right. So there is one attribute which is local to Cisco. Local means it's an optional one. So they are not listed here because it is not a popular one. Wait is also another attribute, as our Arindam said, which is configurable. You can use the wait to tune. Again, it's local to the router also. It's not having that big scope as you see AS path and next hop and origin. These things that are shown here will have a big impact when you configure. But the wait attribute has got local as a scope. We'll talk about that when we go wait. That is a page where it explains wait. But it's not a popular one, and it is not known to every vendor. It is only for Cisco. See the first one. This is not the first one in the list, but first one in our learning. In an attribute list, there is a sequence. In that sequence, wait comes first. But we are not learning about wait here. We are not learning things in sequence matching with the attribute list. We are just learning what they are, that's all. We are just learning what is the AS path. But AS path is not the first one. Wait is the first one in the list. But let us go through this presentation, learn piece by piece, and then we'll arrange it later. AS path attribute. If you see B, router B, when it learns this network 192.168.1.0, you will be seeing the autonomous system through which the update reached B. The update received this, B received this update from autonomous system 65500, which one? This one. And then this one has received it from 64. See, this is what you will see as an update coming when it is received on B. It shows the AS path. So the list of autonomous system that the router has traversed. The list of autonomous system that the router has traversed. For example, on router B, the path to reach 192.168.1.0 is the sequence, A sequence, this and this. AS path attribute is well known and mandatory. Do you have any question on AS path attribute?
Thank you.
So when router C advertises to B, It will advertise even along with this AS numbers. Along with this will also be advertised. When we do the lab, I'll capture and show you these attributes. I'll capture this update and show you, along with the network, the attributes getting distributed. Next hop means what? We learned the NEF. Actually, next hop. We know how the next hop behavior. See, router A is advertising this network. B will be learning with the next hop address 10.10.10.3, correct? Because A is advertising, when it advertises, it will put its own address and send. But we learned that IBGP should carry. So, without changing the next hop, when C receives it, C will receive with the next hop 10.10.10.3 only. Yeah, this network, you will not see next hop 172.20. You will see next hop 10.10.10.3 because the address, the next hop is kept. It is. The next hop is not changed. The next hop is kept same like that as it received from eBGP without altering. B will change. B will send it to C. B sends the update to C without changing the next hop. It will carry the eBGP address into IBGP. B and C are what neighbors? IBGP neighbors. This is the default next hop behavior. With every BGP update, next hop address is advertised. Between eBGP, the address will change. Within IBGP, the address will not change. It is carried. This is not new story for us. This is a well-known story for us. If you want B to change the next hop, we used to say what? Next hop self command. So that instead of 10.10.10.3, it will advertise 172.20.10.1. If you put next hop self on router B. Yep. So this all we have crossed already. We have covered already. Next hop is one of the attribute which is always sent along with the update. This address is sent when this network is advertised to B. B advertises the same to C without any alteration. If you want the alteration to happen, you say next hop self, then the next hop address will be different. Anyway, whether you use next hop self or you don't use, the next hop attribute is always there. Now, about the origin, I told you there are two types of origin. One origin to explain whether this network is local to this router or coming from other router. That's not explained here. That will be explained by me while doing the lab. It's not in this presentation. But this is origin code. This origin code attribute gives us a picture how this network is introduced. See, when you are telling something to me, it can be your own idea. That is what called as using network command, advertising it. Or you are telling me something which you received from someone. That is redistribution. See, when you advertise to me, you and me, or human being. When you advertise to me, when you say something from your mind, that is I. That is using network command. All routers are BGP. One BGP router advertises to other BGP. That is I. The other one, an alien comes to you and secretly he tells something to you. And now, using the human language, you explain me. And you also put this marking saying, hey, it's not my own. I'm a human being, you're a human being, I speak in human being language, all those things are correct, but this is not my own idea. There's an idea from a newly discovered planet. So, we call those as incomplete update because it's not from BGP, it may be from OSPF, redistributed into BGP. So these things are always attached along with the update. That's why it is well-known mandatory. How is this network coming to you? Is it because someone advertising from their own database or redistributing from some other source into BGP? How is this introduced? And we don't have any more a protocol called EGP, so don't worry about this. It's no more. Once there was a protocol called EGP where we used to redistribute from EGP to BGP, where you have E. Nowadays, we don't. I've never seen that EGP protocol. So, if someone uses a network command to advertise, then it is I. If someone uses the redistribution keyword to take some network from some other source like OSPF and give it into BGP, then they are called as incomplete. A question mark. Which one is preferred? Smaller is preferred, and this is preferred. The origin attribute informs all the autonomous system in the internal network how the prefix were introduced into BGP. How the prefix is introduced. How it is introduced? Is it through network command or through redistribution? How is this introduced? Origin attribute is a well-known mandatory attribute. It's well-known and mandatory. So we have seen AS path, which is well-known mandatory. We have seen next hop, which is also well-known and mandatory. We have seen origin, which is also well-known and mandatory. See, when I type this command show IP BGP, I'll see next hop, well-known and mandatory. For this network, these are the next hops. Which is next hop. See the AS. Via this gateway, this is the autonomous system you need to go to reach the destination. If you are going via this gateway to reach this network, then you have to cross two autonomous systems. So it shows the AS path, which is well-known mandatory. It shows the next hop, which is also well-known and mandatory. It also shows how it is introduced. I means what? Advertised using network command. Well-known and mandatory. So for every prefixes, it will have the next hop, the AS path, the origin. Out of many, we have seen 3. And the 3 I also showed you in the output. This is the command which shows the BGP forwarding table. Show IP OSPF. Show IP OSPF. Alright, so up to here, do you have any question till here?
Sir, let's say, for this network, we'll go back to the output, sir. Previous settings.
Yep. Yep.
Yeah. So let's say, sir, the IE, we are advertising this via network command. So 64999 and 64998. So in which age we have given this network command?
Okay. You see, the last number is the place where it is. It's the autonomous system where this network is actually sent out. It's the place where it is originated. And the first number that you see is the immediate autonomous system for this autonomous system.
Okay.
The first number is the immediate. You may have a lot of numbers in the middle, but in our example, we just got 2 hops. If you have 10 hops, the first one is the immediate autonomous system gave you, but actually originated from the 10th hop. The last number.
Okay. Okay, sir.
Right. Any other question?
No, sir.
All right. Fine then. All 3 that we have learned, AS path, origin, and then next up, all 3 are well-known mandatory. Don't forget. We have learned examples of well-known mandatory today. We have not gone to well-known discretionary, like local preference is an example for well-known discretionary. We have not gone there. Yeah, we have seen well-known mandatory today. AS path, next hop, and then origin. With this, we'll close today.